Can you just ping me in your chat window all of your answers? What you get? So, or either I can ask you individually. So, Paritosh.
Actually, I had derived the equation Vishwa,
Okay.
and I was a bit confused. So either it's definitely not order of n, but it's I think like a log n.
Okay. Sai Kiran, what's your answer?
Vishwa, the equation what I got was 3k plus k square, and it was mostly like root n, order root n complexity.
Perfect. Sai.
For me, what I got is big O of n only, because we are iterating from 1 to n, right?
Okay. Jahir, what is your answer?
Sir, it should be square root of n.
Manoj, what do you answer?
Yeah, it's log n.
Log n. Okay.
Yeah.
Okay. Then Vivek, what is your answer?
It will be square root of n.
Cool. So the correct answer of this is square root of n, and I think there's lots of people getting the different answer. But one thing for sure is that s value is starting from 1, and this while loop has to go till that time s value is less than n. If s was increased by 1 every
Root of n.
root of n. Who is saying this?
Ashutosh.
Ashutosh. Okay. If s was increased by 1 every time complexity would have been O of n. But here's a slight difference. S is not getting incremented by 1 every time. Rather, S is incremented by I every time. And I is also getting incremented every time. So I initially was 1, the next time it will be 2, the third time it will be 3, right? So the S was initially incremented by 1, then it will be incremented by 2, later it will be incremented by 3, and so like this, right? So since S is not incremented by 1 every time, it is getting increased by an increased value every time. So the number of operations that will happen inside the while loop will be somehow less than n. It will not be proportional. Okay. Let's say k is the number of operations, and k value will be less than n that we already know, right? Now, if k is the number of operation, this is what will decide my time complexity. So in the first time, the value of s1 was equal to initially 1. Value of s2 is equal to s1 plus 2, right? Value of s3 is s2 plus 3. Can we write like this? So what? Right. Similarly, if suppose this has gone for k times, because we are saying that k times the number of operation is happening. So the k times the number of operation is happening means the loop will run for k times. So suppose kth time the value will be s of k. S of k, which is the value of s at the kth time, I can write as s of k minus 1 plus k, because this is what I'm writing. S3 is s2 plus 3, s2 is s1 plus 2. So sk I can write as sk minus 1 plus k, right? And
Yep.
sk minus 1 I can extend it as right. Sk minus 1 I can again broke into the sk minus 2 plus k minus 1, right? And if we extend it like this, sk minus 2 again I can break down into sk minus 3 plus k minus 2. So if we keep on moving like this, it will ultimately be broken into a series like this: 1 plus 2 plus 3 plus 4 dot 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 till k. This line is clear, guys. This is very important. Clear? Did you see how it get converted into the 1 plus 2 plus 3 plus 4 till k?
Yeah.
Perfect. So sum of the first k natural numbers, what is that? That will be that will be equal to k into k plus 1 divided by 2. So if come out of the loop, and that means sk at that time will be greater than, right? That will be greater than n, right? And we can replace the value of sk k into k plus 1 divided by 2 is greater than n. Now on the left hand side we have a quadratic value of the k, like we have the power of 2 for the value of k, and now on the right hand side I have a linear n, right? as we discussed previously in the last session, whenever we have to find the time complexity, it's always a kind of asymptotic analysis. It's the approximate calculation. You just have to find the proportionality. So in the case, the left hand side is square, and in the right it is a single power. Right? If we take a square root of both of sides, and if we take the proportionality, we can say that k is somehow proportional to square root of 10. So that is why the time complexity of this problem comes out to be square root of 10. Makes sense, guys? Any question on this? Are we good? Because we have to solve many questions. Any problem? Any doubt?
Yeah, Vishwa, that this line 1 plus 2 plus 3 plus 4 and k. So
Mhm.
like how we assume that sk is like going to reduce.
I'll again repeat. So we have not assumed anything. We have
Okay.
followed the pattern. So initially, the value of s became equal to s plus I. Initially, I was 1, and then I was incremented by 1. So at that time, the value of I would have become 2. So s2 is s1 plus s2. Similarly, the next time when the loop will run, I will get incremented to 3. So 3 will get added to the s2 previous value, and which will be equal to s3. So if I say this runs for the k times, the kth time the value of s will be sk, and that will be equal to the previous value, which will be sk minus 1 plus k. Now I'm trying to break these values. Sk minus 1 can be broken to sk minus 2 plus k minus 1.
Yeah.
Right? Then I can further break sk minus 2 to sk minus 3 plus k minus 2.
Yes.
Right? And if we further keep on breaking it, it will reach to the
Yes.
time of s1, and that value will be 1.
One.
So
Yeah.
I'm just expanding that to 1 plus 2 plus 3 plus 4 plus k, and which is equal to k into k plus 1.
Yeah. Yes. Yes.
Make sense?
Yeah. Yeah. Yes.
Perfect.
Vishwa, can you just go just a small question? The third line was the you have written sk greater than n. Please come down. Yeah,
Yes.
sk greater than n, and you have okay. I got that k into k plus 1 by 2, and so like based on what things that you have taken a square root there.
Perfect. So basically, on the left hand side, we have a polynomial equation of the degree 2. Right? It will be k square plus k by 2.
Okay.
On the right hand side, I have a linear equation in the n. Right?
Okay. Got it.
Yeah. And normally, when we're trying to find the time complexity, it's normally asymptotic analysis. We will say. What is the meaning of asymptotic analysis? We do a approximate calculation. We are never going to find the exact value of the square root. So we say that the left hand side is varying in the degree of the 2, and the right hand side is varying in the degree of 1. So if I have to find how the right is varying with respect to the left, we need to do the square root of that.
Okay.
So, but we take the highest degree of that one. If you take k square plus k by 2, right? So
Yes.
we ignore k by 2 in that case. We take the highest degree one.
Yes. That is how we are doing. So we always, in the case of the time complexity, if you have a polynomial equation, you always have to only consider the highest degree, the part of that. The remaining thing you can always ignore because those will be insignificant in a longer range of data.
Okay.
Yeah, Vishwa, you are deriving it in a certain way. I do have one more approach. Like I do it, computing every iteration. What would be the I value and S value, and that mathematical sum. What I do is I leave out the linear part. That is constant one time part, and calculate what could be the sum of n natural numbers, and that's how I'm computing it. Is that correct?
Yeah, so actually we are also doing the same thing. I just wanted to keep it very generic. So this is also the sum of the first k natural numbers on it.
Okay.
Both are same. I just try to keep it more generic. But when you do a little more practice, and this is what we'll be doing it. So every question that we solve, we'll try to find the time complexity of that. Once you become very comfortable, I don't think you have to go this much of route to do all the stuff. It should get visualized, right? By looking at the solution itself with the pattern, you'll get to know that what the time complexity is. Since we are doing it for the first time, we wanted to do it right. So I'm trying to show you that this is how the mathematically it can also be done. It's just not that a theory thing that okay, if it looks like this, you write root n. If it looks like that, you do log n. I don't want to do that because I don't want you to memorize anything stuff. So this is the mathematically how you can derive to any particular time complexity.